Welcome, everyone, and thank you so much for joining today's webinar on this important topic of sustainability in the semiconductor industry. The semiconductor industry plays a crucial role for our digital future, yet its environmental impact is often overlooked. With rising energy demands, high water consumption, and use of hazardous material, sustainability is an urgent priority for the industry. Today, we are so lucky that we're bringing together experts from industry and research to discuss this transition towards more sustainable practices. But before we introduce our speakers, I will hand over to Toni Mattila from Business Finland to set the scene for today.
Yes, thank you, Ida. Yes, this semiconductor industry is expected to be one of the fastest growing business sector in the world over the next 10 years. So therefore, it is crucially important for us to pay attention so that growth is achieved in a sustainable manner. There's no denying of the fact that this industry is extremely energy intensive. All the steps starting from the raw material excavation to the water purification to the exposure of photolithographic steps and all the different elevated temperature and high temperature process steps consumes a lot of energy. But it's not only a matter of energy, it's also these environmentally hazardous chemicals that and other materials that, if not handled and disposed of properly, can cause significant environmental and health hazards. And finally, there's the topic of recycling. While many industries today are looking ways to transform to fully circular, unfortunately, the electronics and semiconductor industry, the recycling rate is well below 20% of all electronic wastes globally. So there's obviously a lot to done here. So these will be some of our core themes for our webinar today, and we have here three distinguished panelists to talk about these matters. We have Birgit Rüdinger, research scientist of sustainable energy technology at SINTEF Industry Norway. Welcome. We have Mona Arnold, principal scientist of semiconductor sustainable business at VTT Technical Research Center of Finland. Welcome.
Hello.
We have Scott Gagliostro, who is a national sales manager and division manager at Munster's Clean Technologies. Welcome to the webinar. Now, before we move on into the panel conversation, we would like to provide each panelist 5 minutes to present the key points of view and perspective on the matter. And we would like to start with you, Birgit. The floor is yours.
Yes. Thank you. I will talk about solar cells, silicon, and sustainability. But first, I'll just say something about SINTEF. It's a research institute, independent research institute. And some key numbers here, 2,200 employees, 80 nationalities, but we're in Norway. But today I will talk about the silicon solar cells value chain, circularity and critical raw materials, circularity and sustainability, and also recycling of the waste streams and end of life of PV, photovoltaic. So this is a very simplified value chain of silicon for solar cells and also for electronics. We start with the quartz and carbon. Quartz is from mining, and carbon can be fossil carbon or biocarbon. And we put it into a carbothermic furnace, and we add a lot of energy. And out comes CO2, which is a direct emission. And of course, this is also land use intensive for mining and or forestry. Then we get metallurgical grade silicon, which needs to be purified to be pure enough for electronics or solar cells. which is also a very energy-intensive step. And then we need to cast perfect crystals. And out from this is a large waste stream with quartz and graphite. After that, we need to saw the ingots, the crystals, and out from this is also another large waste streams, which is sawdust or silicon curve. All of this value chain has a lot of energy usage, and then we have a high indirect CO2 emission. And after that, we have a very complex value chain of making solar cells or electronics, which I will not go into details about. The metallurgic grade silicon, around 40% of it goes to polysilicon, which is very pure, is 9N. It means 99.999 all the way to 9 Ns. This is used for PV, solar cells, and electronics. So it's defined as the silicon is defined as a critical and strategic raw material for EU. And also there is other materials that are critical for EU. Our large waste streams, that's something we are working on to recycle. But I just want to point out that when we're talking about sustainability, we need to reduce, reuse, repair, and recycle in that order. But the things that we cannot reuse or repair, we need to recycle. And we need to keep the materials at the highest value as long as possible. So even though graphite, silica, and silicon is not hazardous, it still is a high value material in the sense that we put a lot of energy into it. It's challenging to recycle materials back to solar grade silicon because there is a very high demand on the purity. But it's possible to use also other high-end applications like batteries, thermoelectric modules, and the purity is the demand on purity is very high for all of these products, but it differs when it comes to which impurities are critical and not. And then short notice on recycling of end-of-life PV modules. It's the active material is silicon, but it's a solar cell is like a sandwich. It's really complex, and that goes also for the electronic. So all the electronics is really complex, and there's a lot of materials inside this, and the recycling is challenging. So what I want you to remember from this is that silicon is the active material in solar cells and electronics. It requires a high amount of resources, energy, material, and areas to produce silicon of very high purity. Silicon in itself is abundant and non-toxic, but is defined as strategic and critical raw material by EU. And to make it really sustainable, we need to circulate products and materials at their highest value. And recycling of the waste streams and end-of-life modules are feasible technologically. Yeah, that's my talk. Thank you.
Thank you, Birgit. Next, over to you, Mona.
Thank you, and let me share my screen. So we are VTT, which is the obvious abbreviation of the Technical Research Center of Finland. We are SINTEF's sister organization in Finland, a multi-technological RDI research service provider, and one of the leading research institutes in Europe, we want to think. So with some 2.4 employees, we are covering most technological areas that has relevance in today's society. One of our spearhead departments is the the microelectronics and quantum technology research area, where we provide R&D services that goes from design and prototyping all the way to pilot manufacturing. We have 250 in-house experts and the largest pilot clean room in the Nordic countries, which is supported by characterizations laboratories. We are also an active player in the Finnish and European research program, and among those where we have a quite active role is the applied materials Chip Zero innovation ecosystem that, with the support of Business Finland, kicked off the innovation ecosystem a couple of years ago to tackle the key semiconductor industry challenges. They relate to the need to increase the focus on environmental aspects, looking at hazardous chemicals, how they're used and not recycled, inefficiency in segregated manufacturing processes, and also above all, also the European dependence on the Asian and American semiconductor markets. The mission is Chip with Zero lifetime emission, and this is enabled by a strong, responsible semiconductor ecosystem in Finland. Today, we are looking at 50 members and institutions and 7 or 8 larger joint RDI projects together with the research organizations and the industry. So the main themes are developing resource-efficient semiconductor manufacturing equipment, processes, and materials. So we are really staying at the beginning of the value chain of the electronic industry, boosting circularity by linking value chains to closed resource cycles, and increasing the positive environmental aspects of semiconductor components, with the focus here on power components and different aspects on electrification. This one of the projects, joint projects in this program is Zero Chip, which I have the honor and joy to be leading circularity in semiconductor fabrication. And we're aiming now, we're looking specifically at the circularity, where there is quite a lot of ground uncovered yet. Developing new strategies and solutions for material recovery, recycling, and industrial reuse. And here we are focusing on high value and critical materials and also water management. Important cases here are the CNP sludge, its recycling prospects and technologies, and noble metals, recovery of noble metals in the ALD processes. We are also doing sustainability analysis of current and developed processes, which will give an input to a sustainability roadmap for the whole industry. So this is shortly from me. Thank you.
Excellent. Thank you, Mona. And then over to you, Scott.
So thank you for having me here today. So we'll start with just a quick snapshot of Munters and who we are. We are a global company with our global headquarters in Stockholm. Currently have more than 5,000 employees. We have 27 factories. We have a presence in 45 countries with more than 150 patents. So what is it that we do? So just to put it at a high level, I'd say Munters specializes in virtually every facet of air treatment technologies. We do things like dehumidification, humidification, we heat, we cool air, all for an array of commercial and industrial applications. And we also have a VOC abatement group, which is my specialty. And In this group, the VOC abatement group, we cater to a lot of different applications and markets, but semiconductor certainly is one of the larger market segments that we chase after. So before I start to talk about the technology a little bit, in a finer detail, I like to define what a VOC is because it's oftentimes not really understood. So a VOC by definition is a volatile organic compound. And to further define what that means, it's just simply a chemical or a solvent that has evaporated and entrained itself in vapor form in an airstream. So the semiconductor industry uses tons of solvents and chemicals every year in their manufacturing process. And they use solvents, they're typically used in various cleaning, etching, washing processes. And the challenge is that they cannot exhaust these waste streams without some sort of post-treatment. So the idea is they want to get these exhausted to atmosphere, but they have to have some sort of post-treatment. And that's where our technology comes into play. So looking at our schematic, I'll run through this as quickly as possible. But at point 1, we're taking the solvent-laden air from the fab's tool. We're taking it into our equipment to be treated. At point 2, we're using our core technology, which is a honeycomb zeolite wheel, which has the ability to absorb those vapor organics. And the zeolite media has a really high capacity to grab those organics out of the airstream. So what we're left with at point 3 is a highly cleaned exhaust airstream. Normally we can get to 99 or even 99.5% removal efficiencies, which is very respectable. At the same time, we pull a slipstream of air at point 4, and we do that for a reason that'll become evident here in a minute. We take that slipstream and we heat it in a heater, or in this case, a heat exchanger at point 5. And then once that airstream is heated, we can use that hot air to regenerate that zeolite wheel. So what we're going to do is we're going to use the hot air to strip those organics, those VOCs, off of the wheel. And in essence, we are concentrating those VOCs into that slipstream of air. And if we compare points 1 and 6 on the schematic, we can say point 6 is normally somewhere between 20 and 30 times lower in air volume and higher in VOC concentration. And the benefit here is we can use a very small thermal oxidizer at 0.7 to destroy those organics before exhausting those to atmosphere. So that is our technology. And, I've been in the industry now for about 11 years, and I have seen a lot of trends around this topic of sustainability. And I'd like to talk about a few of them. I'd say the first one has hit almost every industry, and that's electrification. I think for us, that would mean just simply replacing any gas burning technology with an alternate electrical technology. If it's the oxidizer, if it's the heat for regeneration, these technologies exist today. We still are very heavy in the gas usage of our products. So we are designing most of our systems around gas, but we are seeing more and more requests for electrical alternatives. And I do anticipate that trend to continue. The second category, I would say, has to do with reclaiming waste. So, I think when I take a step back and look at waste, there's waste in many different formats, but I chose to talk about energy waste and resource inputs. For waste energy, there's always opportunities to recover energy and give it back to our process or another process. And we're doing that today. As you saw in our schematic, we have heat recovery systems in there, but I'd say there's more to be done. there still is wasted energy that could be utilized. And one of those opportunities is possibly taking waste heat and converting it to electricity. That technology exists today. I'm not aware that it's being used in this particular application. And if we looked at waste in terms of resources, that one maybe isn't quite as straightforward. And I think there's some work that needs to be done here. But we are getting a lot of requests in the marketplace to be able to recover those chemicals instead of burning them, to recover them and reuse them. So we're talking about that circularity concept. There are technologies that do this today, but they are not used in this market segment. This particular market segment has some challenges with the compounds, the composition of what is being exhausted. And if it could be done, it would be a very expensive solution. So again, I think there's more development needed to fully commercialize a good solution. And then the last one would be around secondary emissions. So if we define primary emissions as the chemicals that come from the process, so those chemicals and solvents that are used by the tools, secondary emissions would be defined as those emissions that are a result of the treatment of the primary emissions. So it could be, in its simplest form, it could be if you have a natural gas burner, that anytime you burn natural gas, there's the byproducts, there's the secondary emissions associated with burning that fuel. And the same thing goes for burning of volatile organic compounds. There is a secondary emissions. And the big ones that are being discussed today, of course, are carbon dioxide, CO2. I mean, that's all over the place in terms of topics of conversation. We're also seeing in the US a bigger focus on NOx reduction. So those are nitrogen-containing compounds, but it doesn't stop there. I mean, there's the whole host of secondary emissions, including SOx and whatever else you have. So that's what I had prepared.
Yes, wonderful. Thank you, Scott. Okay, so we are ready to move on to the actual panel conversation. The goal of this next conversation, the next about 25 minutes, is to explore how we can improve sustainability in electronics, and would there be a way how Nordics could somehow take a leading role in this development. But let's start with a broad perspective. And perhaps question to you, Mona. It seems that there's a lot to do in sustainability in manufacturing, electronics manufacturing in particular. How do you think the industries should start tackling these challenges, and why aren't we further yet in that work?
Thanks for the question. Yeah, a lot has been done already, and but there is still a lot of things to do, as you said, Tony. We are looking at an industry which is showing a really high growth volume-wise. At the same time, it also has a very fast and strong innovation cycle. Every new generation is smaller in size and with a higher capacity than the previous ones. This puts a lot of pressure on the manufacturing process per se to get that going, to get this. They are looking at a very high standard product which is has to be manufactured in very precise and clean environments. So there is very little room to sort of play around and look at and sort of combining both the sustainability goals and the output, the process, the product per se. So this is say from the of industries of different industries to implement really strong circularity and net zero processes. I mean, this is challenging, but it can be done. It can be done, and we are on the good way. Sustainability as such is, practically it's policy and regulation driven, and we have these in place more and more. In addition, we are seeing another very strong driver for increasing sustainability, all from the consumer product all the way trickling up to the semiconductor fabrication is what the end product, the big end product manufacturer are facing from the consumers today. There is a strong demand for sustainable products, and they need to show it, they want to show it, and that also trickles down throughout the value chain. The third driver here is also resilience. When you recycle, when you use less energy, when you use less water, then you can be more sure that you can keep on producing in different environments. If you have a drought, if you have an electricity cutoff. So here we are on a good way, but it's not easy, that's for sure.
Any thoughts on other panelists for the same questions? Scott or Birgit, either one?
Yeah, I would say, one of the challenges here is there's usually a cost to sustainability. And when you have a market that is very cost sensitive, it's, from a competitive standpoint, it's very difficult for one manufacturer to take the path of being sustainable because it's going to add cost to their process, take away profit, and so forth. So I think that's one of the biggest challenges here.
Yeah, so there should be some sort of incentive to take sustainability into production. Mona.
Yes, thanks, Scott. That's a very yes, practical argument, and I'm not challenging it, but I would like to see that in the future, cost and sustainability goes hand in hand, and not being sustainable will cost you more. And if you look at the different aspects, energy, water, materials, the resilience question, you could see, for instance, if you look at the for instance, of the CMP sludge, when the main producer of CMP sludge that country suddenly didn't export anymore. There was like in 1 year several patents out on how to recycle CMP sludge. I mean, this is a question of resilience of the industry. We also see water, it's a very water intensive industry. If there is a drought, the industry is the first to be cut off, then agriculture, then society. So that's also a question, like how can you make sure they can keep on producing?
Birgit, go ahead.
Yeah, it's also for silicon, for example, which is really abundant in the crust, and also non-toxic, and also the waste streams, many of them are non-toxic. So it's very cheap to dump, and it's also kind of easy to mine some of them, at least, or quartz in some areas. So when it's much cheaper to mine in new materials, instead of taking care of our waste streams, it will be a cost problem. So I totally agree that sustainability should really be something that the industry also value higher, because if they only looking at costs, it's cheap sometimes to buy new and dump waste.
Okay, thank you. If we then focus on a little bit to the primary emissions from the industry, they probably come mostly from the chemicals used in the processing phases of semiconductors, and Scott covered some of the technologies well, but what are the means really there to reduce the primary emissions? On one hand, it's very difficult to change the chemicals. How else would you do? But do you see opportunities significant opportunities for emissions reductions?
Yeah, I think there's always opportunities. I think when you take a step back and look at this process, it's already a very complicated process by itself, and we're dealing with very tight tolerances. These chips are continually getting more advanced and smarter. So you look at alternatives, and there may not be good alternatives without making sort of compromise. But absolutely, I think if you look at where some of these emissions are coming from, it's related to what the tools are exhausting and how they're being really treated through regulations. And certainly we can do better with them. If you look at other waste, where other wastes lie, I mean, you could say that there could be some chemical waste management or chemical byproducts that are associated with some of these processes, and they all have to be analyzed and understood correctly on how to safely deal with those, because we've seen it in history too many times where, say, a byproduct or waste stream was just dumped and it was not fully understood, and years later it was found that, hey, we do have an issue here. This was not the right thing to do. So I think there just needs to be more attention associated with what is coming out, if it's air emissions or if it's a solid waste byproduct. Just more attention needs to be given to that area.
Any thoughts from Birgit or Mona on these matters?
Well, Mike, maybe one addition here when you're looking in the EU. I'm referring again to regulations, and I think the smart policies, install them, is also a way to go forward in eliminating hazardous chemicals and materials. Maybe have the regulations on waste on the collection, recovery, and recycling of waste electronics. That if there are hazardous chemicals involved, the recycling is much more expensive and cannot be done, and that then would add to the cost. With the producer responsibility will add up on the producer. Also, regulations relating to hazardous chemicals is quite when it comes to electronics, are somewhat in place. So that is maybe not the fastest way to go, but I think it's one option or one let's say angle to take into account.
Perhaps this is more a question to Scott, but when you apply technologies to remove emissions, you kind of these technologies that you use to remove emissions probably has a carbon footprint also. How efficient are these technologies in terms of energy? Do they outweigh really the emissions, in the sense that the total we would be negative in the total emissions?
The technologies that are out today, they are considered back, so that's the best available control technology, and they do certainly have their downsides to them. But if you look at what we're doing, we're taking a very harmful compound that comes from the process, and we're converting it to something that is less harmful. And that's where those secondary emissions come into play. That's the carbon dioxide, the nitrogen compounds, and so forth. I think that's where I also was saying there needs to be development around that circularity concept. So instead of burning, those organics, what else can we do to get rid of them? And that's where, you know, maybe these recovery systems are the answer. And the systems that are out there today, they do very well with one or two different chemicals or compounds. The challenge with the semiconductor industry is they have 20, 30 different compounds all mixed together. And it's very costly when you have that level of a mixture to recover those and actually be able to reuse those chemicals, because they need a high purity. You can't just have, say, isopropyl alcohol that is 50% diluted with something else. They need a very high purity of what they have. So that's the challenge right now. And like I said, I think more work needs to be done around this topic.
Okay, thank you. If we then move on to the last topical area, it's the recycling. It can be seen as more probably the most challenging, or perhaps the at least an area where there are big opportunities. As mentioned in the introduction, the share of recycling in electronic waste it's surprisingly low. Why is that, Birgit? And what should we do to improve?
Yeah, I think one of the issues, like the size that was mentioned, Mona mentioned that all the chips are getting smaller and smaller. But for solar cells, for example, it's not smaller but thinner. And every new generation of solar cells has slightly different design to make them more efficient. It can be new materials. It can also just be the way they organize the layers. And it means that the automatic recycling is quite challenging. And also the material that we need to produce solar cells it's super strict how pure they need to be. So all this high-end application material need is very pure. But I think one of the things that can be done is to look more to mix the value chains. So there are a lot of applications needing high purity materials, but they might have demand on purities of different impurities. So for example, solar cells, we need very high control of boron, phosphorus and gallium, but other applications might not have the high demand on those impurities. So, but also I think to design the products for a long lifetime, and also to make them repairable and recyclable. So there is a lot of things that can be done, especially on solar cells, that it's possible to repair some of the damages that reduces the lifetime of the whole panel. And you can just take out one cell and repair it if the design is designed for it.
Yeah. Do you think there are the possibilities with any materials within electronics manufacturing to have its recycling circular in a way that we make that material circulate somehow? Are there any opportunities?
For example, silicon, the like the active material. It's no reason why we should dump that material. The silicon itself doesn't degrade. It's an element, and semiconductor is just the impurities that we need to control.
But can we control them well enough? Can we purify it to the required purity?
Yes, absolutely. It's possible. But some of the issues now, for example, in EU, that is the volume is still relatively low. So it's hard to get it cost efficient at these levels of waste streams when it comes to end of life modules. But that waste volume will increase rapidly because we install panels and we use electronics, and so the amount will increase. But the problem is also that it's diversified, this waste stream. But it's technologically, it's there are big challenges, but it's absolutely possible.
Any thoughts on you, Mona, Scott, either one, on the theme of recycling?
Yes, thanks. I fully support Birgit's what you mentioned, Birgit, on that it can be the recycled or recovered materials to be used not necessarily in the same industry or in the same process, but look outside the box, and peer industries where the requirements on purity and quality is a little bit lower. That is instead of putting a lot of effort, money, and technology into having it recycled in the same industry. But there are examples also in the semiconductor industry. They're not very well employed yet due to cost factors and also technology maturity. That it is possible, and I see that 10 years from now the situation is going to be somewhat different.
How about you, Scott? Any thoughts on recycling?
No, I think there's again, just the theme is there's always more to be done. I think I agree with Birgit and Mona's responses.
Okay. Well, briefly on your thoughts on regulation. If things doesn't happen fast enough, there's the possibility that government starts to regulate and start pushing the development. What are your thoughts on that? Role of regulation in advancing things, creating opportunities, or is it a way to create incentives, or put pressure on getting things done faster? What are your thoughts?
Well, I mean, if we can go first, looking at the end-of-life products across different industries. I mean, practically, regulation is the driver. If there is a law, you have to do it. That's when you start inventing. It's just a fact. Then saying that we see also other, let's say, indirect drivers, and that comes through financing instruments that are looking at the taxonomy, how sustainable is that industry, that company, that also can act as a driver. There's more like an economic driver that can in the end also be regulation driven. I'm not saying that. For instance, the taxonomy of the EU is one of that line. I have been looking at the policy environment in US and Europe, not in the semiconductor industry, but in the plastic industry. And it's quite interesting to see how they are taking different routes, but still the same arguments are out there. And without clear regulations and incentives, things are happening in US just as well as in Europe. Maybe Europe, though, a little bit faster. And of course, being the one showing the road, we are also bearing the costs.
Yeah, at least when I look back to the not so distant past, the lead was removed from the electronics industry. CFC chemicals were removed from electronics industry. Halides were removed, all through legislation.
Yeah.
Somebody just said that by this deadline, it's not anymore possible to sell products, including those. Quite effective.
Yeah, now we have PFAS on the way, also going the same route.
Okay, then moving on to the last question, which is now about the low-hanging fruit. If there is one thing that you wish the industry did to improve sustainability today, what would you give advice to industry that what should they do? We're talking about semiconductor industry now. Your choice. Mona.
Okay, I can say one. If you want to if you're looking at the sustainability analysis today, they are very much concentrating on the carbon footprint. If you want to do really an easy, quick repair, I mean, go over to move over to zero carbon energy sources, then you can that doesn't require much changes in your process per se. So that can fix a little bit.
Zero carbon energy. Birgit, what is your choice?
Sources, yeah.
Yeah, I support that one. Since I work with solar cells, to me it sounds logic. But I think also industry should really try to make design repairable and recyclable and increase the lifetime of the materials, because in the end we need to reduce our consumption of materials and land and energy. And also standardize, for example, chargers, batteries, and make products repairable and use less materials within them.
Thank you. Finally, over to you, Scott. What is your recommendation?
I like the recommendations so far. I think, if I look at this from a macro level, from the raw materials to a finished product, there's so much there. There's so many opportunities, and my reflection is just start somewhere and have awareness over it, because the undertaking is just so massive. And there are things that we can do that'll move the needle, but I think it's all those little things that are going to have the impact. So just start somewhere.
Thank you. This concludes our panel conversation. Thank you very much, all the panelists. I believe we all have learned a lot. Thank you.
Thank you. Again, and thank you, Tony, for moderating the panel, and thank you again to Mona, Birgit, and Scott for sharing those insights and talking on several different points in terms of energy intensity, clean tech, circularity, recycling, material use, and not to mention lifetime of material, including also the drivers out there and regulations and the role that has. And we see the conclusions here that this is a topic and an area that we have to tackle together and also bring into forums such as today, where bringing industry and research together to discuss the points and have awareness, I believe was one of the final points there said by the panel. So looking ahead and wrapping up from today's topic, but also looking forward from the Nordic chip collaboration, we do have several upcoming initiatives and webinars, so please go look at the website. Amongst other, there's a webinar on power electronics in June and a Nordic chip meetup in August in Lund. And of course, we also see that there are several events taking place and activities related to today's topic that are taking place in the industry, and one of those is, for instance, the SUSI Summit in September. So please keep involved and stay tuned for several of the topics. And we want to, before wrapping up today, just once again invite you to continue the conversations and to participate in upcoming events, but also to collaborate and share insights. As the chip collaboration or the Nordic chip collaboration, we are really driven by the industry and academia and the research to take part and drive the topics and the areas that you want us to lift also outside of the Nordics and looking in. So please, as always, take a moment and answer the questions on the QR code. We will also send an email after for feedback, but we really appreciate any feedback and also help shaping future discussions and initiatives. So lastly, thank you all for joining, and we look forward to the continued dialogue.